Now this is question 8. This is workshop 2 vectors. Now in this question there are two vectors given, vector b and c. Vector b is given in component form, ijk form, tan alpha I cap minus j cap plus 2 root of sin alpha by 2 into k cap. Vector c is given like this, and it is mentioned that vector b and c are orthogonal to each other. They are perpendicular to each other, and there is another vector a that makes obtuse angle with z-axis. Now two vectors perpendicular to each other, that is b and c. There is another vector, third vector, again alpha is involved in the component, making obtuse angle with z-axis. Now we have to find the value of alpha. It's like if b and c are perpendicular, the dot product is 0, right? And you know, when vectors are in component form, dot product is a1 a2 a1 b1 plus a2 b2 plus a3 b3, I components multiplied, and then multiply j components and k components and add. So it means what we get is tan square alpha minus tan alpha, and product of these two is minus 6 equal to 0. We can factorize this. Tan alpha minus 3 right, into tan alpha plus 2 equal to 0. So either tan alpha equal to 3 or tan alpha equal to minus 2. Now we'll get two answers from this side, alpha from this as well as alpha from this, but we need to consider this condition also. A vector is making obtuse angle with z-axis, so it means a dot j cap, right, should be less than 0. You know, angle between two vectors formula. Suppose there are two vectors a and b, then this is the formula to find angle, this is equal to cos theta. And you know, as denominator is positive, if angle is obtuse between two vectors, it means theta is obtuse means cos theta is negative, so it means a dot b over mod a mod b is negative. Denominator is positive, so it means a dot b is negative. So dot product of two vectors negative means they make an obtuse angle with each other. So these two vectors make obtuse angle with each other, so the dot is negative. So you can see dot of this with it is z-axis k cap, so it becomes sin 2 alpha. So sin 2 alpha is less than 0. So sin 2 alpha is negative and tan alpha is this. Now we have to check which of the two we have to take, or both of them we have to take. So we'll draw graph of sin 2 alpha on the same scale. Sin 2 alpha is a graph of sine, but period is 2 pi divided by period is pi. This graph of right, the same scale we can draw graph of tan alpha, now sin 2 alpha is negative. Sin 2 alpha is negative means, so we have to choose alpha. This axis is alpha. We have to choose alpha only either between pi by 2 and pi, and this is 3 pi by 2 and 2 pi, right? So in between this, when between pi by 2 and pi, you can see tan alpha equals to 3. Tan alpha equals to 3 means these points, these values of alpha, you draw 3 line. Now these values of alpha, for these values of alpha, if you find alpha for tan alpha equal to 3, what I mean to say, for tan alpha equal to 3, if you find the corresponding values of alpha, they don't lie in this region. Same here. So tan alpha equal to 3 is rejected because the values of alpha it gives from graph, we can see it, these values don't lie in these intervals. But when you draw tan alpha equal to -2 like this, you're getting those values of alpha which lie in this interval. For example, this point of intersection lies in this interval, so we can have those values of alpha from here for which sine 2 alpha is negative. So tan alpha equal to -2 is the right answer. So tan alpha equal to -2 means alpha equal to n pi plus tan inverse -2, n pi minus tan inverse 2. So if you look at A choice, 4n plus 1 into pi minus tan inverse 2. This is correct because you can this is the right solution because this satisfies, because we can always get rid of a integral multiple of pi. So it can be any integer. It can be this is also an integer, so this is part of this. Same here, 4n plus 2 alpha minus tan inverse 2 is a possible value of alpha. So answer is A and B, right? So any integral multiple of pi, when any integral multiple of pi would satisfy this. 4n plus 1 is an integral multiple of pi, 4n plus 2 is also an integral multiple of pi. So these two are not the complete solutions but part of the solutions, right? So it's a more than one choice correct question will choose this as the answer, this is the answer, because these are the possible values of alpha.